Welcome back to Ox Tools, I'm Tom. So we got Meatloaf here for you. Bunch of cool stuff that changes in the shop, some viewer mail, working on another collaboration project with another YouTuber. What else? And there'll be a little bit of machine work in here. We're gonna take a look at putting a corner radius on an end mill when you're up against the wall. How'd that happen, right? And let's see what else. Oh, and then some, just a little bit of machining from the collaboration project. It was a simple part, but there was one operation on it that was kind of interesting, kind of fun, that you guys will get a kick out of. So let's dive in, let's check it out. This first thing here is kind of interesting. You know, for a while on YouTube, the advertising prior to the videos was, these things were showing up there on pretty much every darn ad, and I think Adam Booth showed one of these on a video recently. So what these are is it's a deburring tool for the outside of an object, not a finger, but you know, if you were going to put a little chamfer like that, right? That's the general idea, and it fits in a cordless drill. It's got three flats on it so that it doesn't slip in the chuck. But and somebody sent me this, and forgive me, but I forgot who it was. But what struck me was this is like a super cheap tool. Okay, I mean these things are $5, $6, $7, $8, something like that, or 3 for $10, or you know, I don't know what they are, but you can look them up, and they're pretty cheap. What I wanted to point out, what I thought was really interesting, was how they made this damn thing, okay? And excuse my French there. So this is, okay guys, the guys that are entrepreneurs out there and they want to start their own machining business, okay? Don't focus on commodity items, right? I'm going to call this a commodity item because it's mass produced, right? So if you'll take a look at this, you'll see how, I got to believe this was made offshore, right? Somewhere. That's the only place you could economically produce something like this, right? But look at how this is made. So this is 4-axis machining here, guys. All right, and you can see the tool paths that they use to create this thing. So what that means to me is these are machined from solid, okay, and maybe machined in the probably not in the hard condition, but and it looks to be plated. So you think about all those steps, right? You got to buy some material, you got to program this thing, and your spindle is doing one of these at a time, right? So this is not a good use of your entrepreneur machine shop time, right? So this is your competition, and they sell them, okay, say they sell them for $10, right? What that means is the distributor bought them for $5, okay, and the manufacturer made them for $2.50, kind of on the outside, right? So everybody's keystoning the, you know, as they go up the chain. Now, if I bought this for $9 and I was going to resell it at the flea market on my table, I'd want 15 or 20 bucks for it, right? And you know, so everybody's jacking it up 100%, right? So, or doubling the keystoning the cost. So it's kind of scary, actually, that they have that much time, right, that they can produce this part that way, right, instead of some other manufacturing method here, right? Or maybe I'm like totally off base here and they just did this because it's cool, right? And those tool paths look cool on there. I kind of don't think so. So fine, maybe they got a whole bunch of these lined up, you know, on some a multi-spindle indexer or something like that, right? They have those, you know, with 6 or 8 spindles that rotate in unison, and then the spindle works on one thing at a time or whatever, one at a time. But so Tom's advice to entrepreneurs wanting to have their own machine shops is find a niche, okay? Have a machine that's bigger or smaller or more precise than everybody else, right? Everybody in the world's fighting for the flat aluminum plate with 4 holes in it, right? Don't compete there. Compete somewhere that nobody wants to compete in and get good at it, okay? So anyway, there's your competition right there. This next one's this next one's kind of funny actually, because it's more of a joke than anything else. So we got this little book here, shop terms, and you know this is an official book here, right? So this is Department of Education. Looks pretty official, right? So having a YouTube channel and not being very good at pronunciation, so you guys all know that about me probably if you've watched my channel. And frankly, it doesn't matter that much to me. It's more entertaining for you guys, right? When I botch a word, but one I get all the time from our English and Australian folks is the pronunciation of the of this metal here. Okay, so this is AL on the periodic chart, okay? And but what I thought was funny is in this book, and let's go find it here, is they have, so what we have is a whole bunch of, yeah, I had to change the exposure on the camera here. And they have how to pronounce, you know, some common technical words, right? Like aluminum. And so let's see, let me find it here. So there it is. So, you know, we always, you know, the Brits and the Australians always give us crap for how we pronounce aluminum, right? So I'd like you guys is to work along here in your respective places where you're sitting and pronounce that word, okay? Aluminum, okay? So that's official, okay? That's official by the Syracuse Education Department, right? So, you know, if the Brits or the Australians out there can produce a similar reference material on the correct pronunciation of that word, I'd be happy to take a look at it. So, like I said, this is more of a joke than anything, and I do believe that the Brit pronunciation is technically correct, although it's not the accepted standard pronunciation here. Okay. Oh, let's look up another one here while I'm there, because I think. Yeah, here's the other one, right? Although it doesn't say, there we go. It's hard to do this upside down. So the Brits say soldering because there's an L there, right? Soldering, okay? That's American, all right? Probably wrong, but it's American. The L is silent, okay? Anyway, have fun with that. I got a laugh out of it. Hopefully you got a laugh out of it. So, okay, so this is kind of cool. This is a collaboration part with Saunders Machine Works, and John contacted me and asked if I wanted to be part of the Johhny 5 kind of machining collaboration, and I think he's asked a bunch of other YouTube folks to if they're interested in helping out, and they said, yeah, sure, I'll help out. And so anyway, this is the part that they sent me. I said I don't have a lot of time, so don't make it Apollo-like. Let's just put it that way. So this was all done manually, just you know, for folks out there, and so it has a couple of little challenges in it that that you guys might be interested in. So what are those challenges? So the first challenge is now this is typical of and this, you know, I don't mean this as any slight or any negative on the designer that designed this part necessarily, but this is typical of CAD people, right? People that use CAD a lot, right? And maybe don't design parts for machining, okay? So you see some kind of root radiuses here, right? And but in particular, the root radiuses that don't have a round corner here, right? So, you know, if you're producing this on CNC, right? You know, a lot of this stuff is fairly easy, right? But this part, it has radiuses here, it has this radius here, so this is at least a two setup part. Actually, maybe more than that. Let's think about that. So you can do this all from the top. So let's say you 3D profile this whole thing. So you can get all this stuff in one setup, right? You can't get the hole, so you got to either rotate it up like this to get the hole, and then whatever you're holding on to at the bottom. Let's see, how would you do that? I'm thinking 3-axis here, actually. So if you have a 5-axis, you can probably do it a different way. You can leave a tab on the edge or something like that. Anyway, I haven't really thought it through for CNC ops, but I did it manually, so that's all that really matters here. But this is kind of an odd radius here, which presented a problem. So, and I'm gonna show you how to do this here. But what I did was I just put, I had a normal 2-flute end mill here, and I just put a corner radius on it that was equal to that. Okay, easy enough to do, right? And the reason I want to show you guys is because we've all kind of run into this, as somebody throws a radius on there and it's not something you have a tool for, right? So you either have to order something, or if you need to get the job done, it's easy enough to put a corner radius on a 2-flute end mill, or a 4-flute for that matter. Doesn't really make much difference, right? And I'll show you guys how to do that, because I got another tool here that we can just throw a radius on that and kind of show you how to do that. So what else was I going to say about this thing? I don't know. I think that's it. But it's fine. Don't worry about it. We're going to send this, and it's going to get put together. The due date was November 30th, so we're pretty close to that right now. I used up all my my cushion, and we're going to send that off, and it'll go on the robot, and it's part of some laser bracket or something like that. I don't know. This piece was just to support that while I machined it, just so you guys know. And then this was the machining fixture I did to do this radius here, and we're going to see that right now. Here's what you're going to need. So you need your tool, obviously, and then you need a radius gauge so that you can excuse me, you can check the corner radius. So the first thing I do is I just take a look at it and go, all right, well, I can see how much I need to grind off, right? The trick is to not go too far. You want to kind of work slowly, right? So there's a roughing stage, which we'll do on the bench grinder. Then I use the diamond lap actually to do the last little bit, so I get a nice smooth finish on it, and it doesn't leave lines in the part when you're machining. Okay, and then you need to test the tool as well to make sure that it cuts properly, that you have you have relief behind the cutting edge. Okay, so what we're seeing here is you see a primary relief, which is that little land, and then a secondary relief, right? In our case, we're just going to because it's not a production tool, right? So we'll probably end up with more of just a single relief that's probably equal to something like the secondary relief. It's a slightly larger angle. We want to be able to see the relief, I guess, is what I'm trying to say. So there's primary and then secondary relief, secondary and then massive clearance relief there. So there's kind of three there. Actually, there's only two. Okay, so so that would be the primary, and then that's the secondary, which is big. So yeah, that doesn't have three. So that little light edge, secondary, okay, primary, secondary. Okay, so let's go over to the bench grinder, and then we'll. I think I'll just do one corner. Okay, just you don't want to watch this forever, right? We'll just do this quick, and then you guys can try it on an old end mill, and then do a test cut and see if you can handle that. We're going to use the tool rest here, right? And so you got, this would be 0, and then this would be 90 degrees. So you always want to be a little bit careful you're going to come up a little bit short of 90 degrees, right? So what I like to do is kind of hold the tool with a slight amount of clearance, okay? Not a lot like that, but just a little bit so that you have some clearance, right? And then what I do at first is I just do a couple little facets, right? So I facet it to kind of rough in that radius, right? And then I'll do a sweep to smooth it out. Now, I suggest a pretty fine wheel, right? You don't want this to go real fast here, right? So last thing is, look at the kind of radius that you're looking for here, right? And kind of judge what you're doing there. So let's go ahead and do this here. Get my magnifiers on here. So I'm going to hit it at kind of 45 to start with. So now this is where I got to be a little bit careful, right? And it's never too early to give it a quick check and see where you are, okay? So let's take a look at the back side there. Okay. So judging from that, I got a little bit of downhill angle to it. So and I'm taking away, or I'm grinding along the secondary relief there. So I know I got clearance. Okay. So I'm pretty confident that that's a good angle, or working angle there. So you see how it's a point, so the grinder takes it away pretty fast. So you got to be careful. So see, we're already getting pretty close here. And in fact, as I see, I need to come around this side a little bit more. I think I'm going to do that. Then I'm going to shift over onto the diamond wheel because it works a little bit slower. Let's take a look at that. So there you can see the back side. And you see it's kind of bumpy because I'm hand holding it, but that's okay. What do we got here? And I'm going to go a little more. Because the diamond wheel is pretty slow too, that's the other thing. So it's always this judgment, how far do I go here? Better to, honestly, I could go for a finer wheel in this case, but it's okay right now. Alright, we're sneaking up on it. Yeah, I think I'm going to shift over to the diamond wheel now, okay? Like I said, I'm only going to do one flute, and you want them equal, or as equal as possible. So let's go over on the diamond wheel, and then we'll finish that up and see how it looks. Okay, so this is where I have this AccuFinish grinder. There's not a lot of space around it to get the tripod. So I'm just cleaning the wheel a little bit right now, and you can see it's slow speed. This is a 360 grit wheel here, right? And you see the smudge coming off there. That's and this is a Premier synthetic grinding compound, or grinding fluid. Okay, so let me try to pay attention to what I'm doing here. So I got the table set at a little angle here, just so I
So I think now ideally you'd be doing this on an optical comparator, right? To do a real nice job of it. You know, I think I'm going to switch to a finer wheel here because I'm right there. Yeah, I took it pretty far on the bench grinder. Yeah, it's looking pretty good. So and even this one is cutting a little aggressively here. So let me swap the wheel. I'm going to go to a 600 grit and we'll come right back. Bam! Back already. The wonders of video editing, right? So once again, I'm just going to clean it. And actually, your finger works pretty good for getting the, you know, if you use paper or cloth or something like that, it tends to get stuff in, kind of hung up in there. Oh yeah, that's better. The trick is that you can pay attention to what you're doing and it's not cutting so fast that you lose control of it. Oh yeah, that looks real nice. Okay. And we'll wipe it off. Yeah, that's pretty good. It needs a little more in that one little spot there. Now this is no Alfred Lion AB Tools substitute by any means, but it will get you cutting if you're in a jam. Okay, so I'm real happy with that now. There was a little, and you guys can't see it on camera, but there was a little bump. It wasn't quite symmetrical, so now I'm pretty happy with that. So let me go back on the bench and then we'll zoom in on that and you can get kind of a close-up of it and get a sense of what the finished product looks like there. So stay. Make sure I'm in the darn frame there. All right, so there's the radius that we just did. Let's come up. And, okay. You guys happy with that? Because I am. It's pretty good. Okay, and then let's turn it around and you can kind of see my my chowdery relief there. Okay, but it's smooth. It's pretty smooth. I mean, there'll be some small lines in the part, but it's completely serviceable. So, and you saw that only took a couple of minutes to do all that, right? So I did just do one flute, but you know, 2 is not a heck of a lot. It's not twice as long to do 2, okay? And then what I would do in this case is I would mark this end mill, okay, to put it back in the drawer, right? Just so when I look at it in the drawer, I go, oh, hey, it's got an 1/8" radius on it, and I just grab it and go. I don't have to get the radius gauges out. So do yourself a favor, label stuff when you put it away, and you're really only saving yourself. Okay? So this one is, I don't know, what would we call this? I don't know. So this is a little bit of history here, right? When you could get real chemicals for the shop. Now with EPA requirements and hazardous materials and things like that, the choices are different, let's just put it that way. So one of the things that I've been doing is, I'm working on an estate sale for a friend of mine that died a while back. And one of the first things that we had to do in the shop there was to clear out all the hazardous waste, right? That was kind of our first step. And if anybody's people out there with shops, they understand how many chemicals and fluids and buckets of unknown liquids that they have around, right? So imagine, poof, you're not there anymore to explain that, oh, that's a bucket of gear oil, or that's such and such coolant in water, or whatever it is, or that's, oh yeah, that's, rat poison in a little in a little yogurt container, right? That I mixed up, right? So just imagine going in somewhere blind, right, and having to clear all that out. Well, this is something I found in that estate.
while we were cleaning up, and I decided that I wanted to keep it. It actually works really good. So, but this is pretty ancient here, and I don't know, it's about 3/4 full. So that was another reason to take it. So, but what this is it's let's take a look at the other side here, and this can be hard to. This is perchloroethylene, right? And basically, it's kind of dry cleaning fluid. There's some interesting things on the labels here. Let's see here. Darn it, where the heck is it? If you experience headaches or dizziness, increase fresh air. And then there was something about deliberate use. So anyway, I'll let you guys read the thing, but this is pretty, well, at one point this was, considered safe to use, right? And now if I was using this, I would probably wear gloves and have a fan going so that the fumes weren't, oh, there it is, deliberately concentrating or inhaling the contents. Oops. Yeah, not good. So anyway, some ancient gauge block cleaner, and it's pretty intense when you use it. But I'll tell you, it is an awesome degreaser, and it takes everything off and doesn't leave a film, which is kind of the important thing. So anyway, I thought you guys would get a kick out of that. This is the old Sheer Tomiko label that you don't see anymore either. So what this is a motor and gearbox for my Lapmaster 15 lapping machine. So I don't think I've shown that machine on video yet, but I will soon. I bought it at a local company that was closing down, and they were selling off some equipment, so I got it for a pretty good price. And so I've got it all taken apart now, so there's not a heck of a lot to look at, but I'm just kind of giving you a little primer here that this is coming up. We're gonna try it out pretty soon because it's almost ready for prime time. But what happened to this gearbox was pretty spectacular. So you turned the thing on and it just sounded like a bucket of bolts running. So it was clearly there was something wrong with it, right? So what had happened was the previous owner, they didn't clean out the used abrasive and slurry, basically. And it kind of hardened and caked up, and then it overflowed a weir that protected the gearbox. So what happened was this abrasive material ended up pooling up in here and filling up and then just working its way through the seal and going into the gearbox. So I put a little post up on Instagram for those guys that follow me on Instagram. They probably saw the pictures of the bearings that were completely blasted. So anyway, I got it all back together. The surprising part was the worm and the gear were in pretty good, still in reasonable shape or usable shape. So replaced all the bearings, all the seals, cleaned it, hot tanked the thing, just, did a proper rebuild of it. So it's all going back together. Now, what you see here is, so it has opposing tapered roller bearings because there's some thrust loads on it, right? So there's a set or a package on this side and a package on this side. So there's a particular distance between those bearings that has to be controlled, and then the gear still has to be centered on the worm coming in this way, right? So there was some kind of tricky measuring and whatnot, and the way the manufacturer handled it is they used peel shims. So those are basically shims of a particular thickness that are laminated together, and then you peel those shims to change the spacing. So those were kind of chowdered when they came off. So what I did was I took some measurements and I actually machined solid ones on either side here, and you can see that there's one's thicker and one's thinner, and to get the bearing clearance correct while the worm gear is centered on the worm. So does that make sense? I hope it does. So anyway, that's a lot of yapping for, I fixed the gearbox. So then the motor bolts on here, and then this bolts underneath, and the lapping plate attaches to this drive shaft. I rewired it, cleaned it all, and it's going all back together now, so maybe the next video that comes out, we'll have this thing running and you guys can take a look at it. We'll probably won't lap anything on it because I gotta do a little, build a little pump for diamond slurry, and then we'll do that. But then we'll try lapping some stuff, or we'll correct the lapping plate because it's not flat, and then we'll lap some stuff and then check it and see how we do. So anyway, that's coming up, and gearbox rebuild. Okay, so actually this is just an announcement here. So some of you may have heard the name Richard King. He teaches scraping and machine alignment and machine rebuilding. And he actually has, this announcement is that he has a class coming up here in Northern California, Vacaville to be specific, and it's in April 2020. So if there's local Bay Area folks that have wanted to learn the art of scraping, and truly it is an art form, and Richard is he's an old bugger, and he knows a hell of a lot about scraping and machine alignment, and he's also got some great stories. He's a hoot to work with. Anyway, he's having a class in April 2020 up in Vacaville, and I'll put a little link in the description so that you can contact him if you're interested in signing up for this class. I'm planning on attending the class just kind of as an observer and helper, and hang out with Richard and tell war stories and do a little bit of scraping. So he teaches hand scraping. Okay, and then he also teaches power scraping, which is about 1,000 times faster than hand scraping, although requires some equipment investment. Anybody can come up with enough money to make a hand scraper and go to town. My belief is the real value in the class is his knowledge about machine alignment and machine rebuilding. So if you decide to go to the class, that's really what you're going to want to pick his brain for. This you can practice on your own once you get the fundamentals, but the really deep knowledge comes in, which surfaces do you scrape first, and why, and what alignments are you looking for, how do you do those alignments, and how do you, there's just a million things other than learning the physical mechanics of scraping, right? That's something that you can practice and kind of perfect on your own, but the real gems are that trade knowledge that you're looking for. Anyway, look in the description. There's a link to contact Richard and get signed up for the class. He does require a deposit so that he can plan his travel and all that. So. But you're on your own, you work that out with Richard, and hope to see you there. What I wanted to show you over here was, this is my Brown & Sharpe Micromaster, and I've got flood coolant on this. And so for those of you guys out there still, trying to do dry grinding, dry grinding works okay for small stuff, but when you when you get into bigger surfaces or heavier material removal, you really should go coolant. And keeps the part cool, keeps the stuff out of your way, and better finishes. There's all kinds of advantages. So, but I just wanted to show you the setup because I created an Ox Tools rendition of a coolant tank with a pump and a nozzle system here. That you guys may be interested in. So I may have shown some of this a long time ago when I was working on this, but we'll go through it and we'll take a look at it, okay? Okay, the first part is the actual nozzle here. Now, I'm not smart enough to think of this idea myself. This came from Robin Renzetti, and in fact, he even sent me these tubes. And they're Siamese together, and they're soldered together and then soldered into this brass block. But what it does is it allows me to direct the flow right at the interface between the wheel and the work, right? And then this distributes it widthwise, so that I cover the whole wheel there, right? You know, I got them beveled off. And then this is me here. This is actually from a photo, photography, like, B&H Photo. I think they had these on sale for 20 bucks or whatever, but it's basically a Noga arm, right? And so now I can get up under there, put it right where I want it, and lock it down, and Bob's your uncle, okay? And then back here, I have a valve, a ball valve, that I can control the flow with. So that's full flow, and then that's off, or teeny bit of flow, whatever you want. So I can control the flow here locally. And then what I did was I put the pump on a little wireless remote control. Now I don't want to turn it on right now because I want to show you the tank and the weirs in the tank and the settling volumes that are in the tank. Okay, I want to show you that part before I get everything the whole system wet again. Okay, all right. So anyway, so when I want coolant, bing, I hit the remote control, coolant comes on. Bob's your uncle, turn it off, and I don't have to reach for a valve or reach for a switch or do anything like that, and it's right on. Maybe that's maybe what I ought to do is put it on a little magnet here or something like that, and then I can stab it here. Although I just keep it on a shelf down below. Okay, so let's look at the tank and maybe give you guys some ideas for your own. This is all very cheap to make and with readily available materials. So. All right, the first thing to note here is it's on wheels, okay? And this is just a Harbor Freight furniture dolly, and it's actually kind of a crummy furniture dolly, but it works great for putting this little coolant tank on, and you can see it fits pretty good. So coolant returns here, and this is a flexible hose that I can just pop out of there so that I can bring this out and mess around with it, okay? And then this is just a cover for the strainer and filtration. Okay, so let's set that aside. Okay, let's pop that out. And these are just a couple of strainer baskets here so that I can hold the screen in the right shape, and it has a collecting point. So now you can see. Get rid of that. Now you can kind of see inside here. What this box is. This is just a partitioned parts box. Sure, I'm still in the frame there properly. Yeah. It's a partitioned parts box from Macmaster Car. I think this was 12 bucks or 13 bucks, and then the dividers, which are notched like this so they fit together so you can create different size openings in it, are a couple bucks a piece. All right. So, and then the lid's a couple of bucks too. So. But there it is. So I got a submersible pump. So kind of dirty coolant comes in, kind of gets strained in the strainer, and then drops into this pocket here. And then coolant fills up and spills through the notches in the weirs. Okay, and they're just below the surface, right? So anything heavy drops to the bottom, fills up into that one, then that one fills up into that one. So by the time it gets over here, it's relatively in relatively good shape. Now, grab this here. So I attached so gluing and sealing plastic can be a challenge. This is what I use there. This is 3M Marine Adhesive Sealant 5200. Works great. Takes a long time to dry, but it works great. And it bonded this polyethylene here perfectly, and then you can see there's little slots that these fit into, so sealing it up wasn't really a problem. And the pump is the most expensive part, and I want to say that was 80 bucks, and I bought it for another project, but so I just kind of reused it here. So that was the most expensive part of the whole thing, and that is what I'm currently using for my coolant, and I'm pretty happy with it. It works pretty good, and I just plug that back in there and roll it back into place, and Bob's your uncle, right? So let's turn it on, and you can see the remote control and all that stuff. There it goes, and then off. So This thing just came from Amazon. It's just a remote control for, you know, a light or a radio or something like that. And I don't know, I think it's good to 10 amps or something like that, so it's pretty good. And zoop, there it comes. And then I can switch, get more flow, or I can shut it off here locally if I want, or just get a teeny bit if I want just a teeny bit. So just depends what you're doing. Anyway, so there you go. Give you some ideas and for your own shop. This next one comes from a friend of mine, Phil Kerner, otherwise known as the tool and die guy. And he's an interesting character. He's been in the trades since he was a teenager, working in his dad's shop, I believe. And he's out in Erie, Pennsylvania, and he does these, you know, I call them, and he calls them boutique calendars each year. They've been successful for him, and a lot of people are interested in them. They like tools, and you know, everybody needs a calendar, right? So this is the 2020 calendar here, and this one's a little different than previous years. They've been the kind of the flip ones with pictures of tools and things like that. And I have to say that my preference is this whole year calendar. It's kind of useful in my mind. You know, you're kind of tracking progress throughout the year, right? And when you're only looking at 1 month at a time, sure, the squares are bigger, but you're just looking at 1 month at a time. You don't get a sense of how fast your time's going, I guess is what I'm getting at. So anyway, Phil does these calendars. I think he's got a bunch of them, so if you want to send a nice Christmas gift to somebody, there's a link in the description. Check it out and help a fellow metal worker out and buy a calendar from him and make somebody's day when they get it. So, or just buy it for yourself. Anyway, they're reasonably priced, and you're helping out a fellow tradesman, and that's always, you know, nice thing to do. So there's another bit to this here. Let me trade here. Careful, yeah, mess these up. And so I bought both of these, okay, and this one is it's a nice cutaway of a Lufkin micrometer, right? And and you know, it's just shop art, okay? So this one, you know, this one will last more than a year, right? And what's interesting is that Phil's actually, he's a Lufkin fan, and so am I. This is a brand that used to rival Starrett and Brown and Sharpe, and now their big business is, well, that's a Stanley, is tape measures, okay? That's all they do anymore. So if you're looking for tools, high quality machinist tools, check out this name on eBay. They make some beautiful stuff. In fact, their satin chrome and their graduations are some of the best in the business. And in fact, I think they are the best myself. I have some Lufkin micrometers that are just absolutely gorgeous in comparison to the other guys. So once again, you know what? I don't know what he charges for this, but it's totally reasonable. And yes, this is I'm helping a friend out, and so there it is, right? Big deal. So if you don't want to help them out, don't do it. If you do, go for it. All right? So anyway, Lufkin micrometer and a calendar, good shop stuff. So this next one, this is basically kind of a shout out to a good vendor, okay? So, and you know, it's not any kind of a sales pitch or anything like that. I just want to communicate an excellent experience I had with a vendor, okay? So you guys know I have it's a DROpros digital readout on this YAM lathe, right? And so I don't know, I've had it for actually quite a few years now, and it functions wonderfully, okay? It works fine. But recently, I had a problem with the x-axis, and it was skipping counts and generally misbehaving as a DRO, right? And so typically you go in and you clean things and you realign things and then you try it again, and I did that and it helped a little bit, but then it came back again. So wasn't quite sure what was going on, right? So they have I guess it's a tech help email, and I just emailed them, and they got back to me right away. And my question was basically, hey, my x-axis is skipping. I have magnetic scales, blah blah blah. It's skipping. Give me some idea what to look for here. Help me out. What could be causing that, right? And their answer was, we don't know. And but we're going to send you a new read head right now. And they did. And so they didn't mess around. I was having a problem. I did tell them what I had tried to correct the problem, but they didn't really have any additional advice. They said, we have no idea why that's happening. It sounds like you did everything right. We're just going to send you a new read head, which they did. And guess what? They fixed the problem. So now they're local here in California. They're up in Fairfield, I think. And nice bunch of guys, been over there to their shop and looked at some of their machine tools and the DRO choices and probes that they have and things like that. Just a couple of nice guys. So if you're looking for a DRO, check them out, okay? For the money, these are excellent DROs and excellent customer service. Ox tool, thumbs up, okay? So take it for what you will and, go from there. You're adults, make your own choices. All right, see you later. This is pretty cool here. I think you guys will like this. This was sent to me by a friend of mine, James Urich, and he's in Colorado. And he said, "Hey, somebody's getting rid of some cool stuff. Are you interested?" And it's like, what to bait your hook with, right? Of course, I want to see, right? That was the short answer. And so we did a little horse trading, so to speak, and James got something he wanted, and I got the mystery item here. So what we have here is something that's actually pretty special. Let's take a look. So for those of you that don't know what this is what's called an optical polygon, okay? And it's a very kind of special reference standard, okay? So it's an angular reference standard, and I'll show you how that works in a sec here. So this one, so some of them are made out of glass, some of them are made out of carbide, some are made out of steel. This particular one is made out of steel, and made by a Coventry Gage company, also sometimes goes by the name Matrix, although maybe that's what they call their tools. I don't know. It's one and the same company, Coventry Gage and Matrix. You see Matrix gauge block sets in Australia and in the UK, very rarely here. So made in the UK. So it says based on, I'll turn it here, based on NPL design. So NPL is the National Physical Laboratory. So this is like the Bureau of Standards in the UK. So now this one's cool because it's got 10-degree increments here. So it has a little flat face here, and I'm gonna pick it up here. It's not super easy to get out of the box here. Let me tip it up, and you guys can see it. So it looks like it's a polygon, as the name would lead you to believe. But what we have here is we have ground, lapped, and polished faces that have a very, very accurate angular index between each face, okay? And and they're reflective, and they're supposed to be reflective, because what we use is we use an autocollimator to look at this, okay? So that surface needs to reflect back like a mirror, okay? So the way this is used, so yeah, how the hell do you use it, right? So there's all kinds of ways you can use this. So you can actually attach it directly to something that you want to index, okay, very accurately. So for example, say we wanted to index this very accurately in 10-degree increments. I mean, very accurately. What you might do is attach this to the end, okay? Not maybe a good example here, okay? Attach this to the end, then we would look at those faces with an autocollimator, then we would rotate it, and then the autocollimator can discriminate fractions of arc seconds of angle change. So we would zero on one face, and then we'd make an index, and we'd zero on the next face, and this would be a very, very precise 10-degree rotation. So that's one way you can use it. The bigger way that they're used, and let me pop this out here and get this out of the way. Actually, you know what? I'm going to set this on this because it makes it easier to pick it up. The other way you might use this here is to calibrate a rotary table, okay? So here we have, now this particular rotary table is also very special, but it was the only one I had that was big enough to kind of set this on kind of properly, right? In fact, this is probably the same accuracy and possibly better than this. So just to kind of put it in perspective. But the way we do this is you put this on like so. You put it on center like that, and then I need an analog here. Let's pretend this is our autocollimator looking at one of these faces, right? So we would zero up on one of those faces, and then what we would do is we would make an index with this, and then we would take another measurement on the next face. So we'd make an index equal to the spacing of the faces here on the polygon, right? So in this case, it's 10 degrees. And then we would note any angle differences that we measured, okay? Now, what's cool, this is one of those kind of natural things that happens is everybody knows that 360 degrees is a full circle, right? So it's a principle called closure, and circle closure in this case, right? So once we add up the errors, plus and minus, plus and minus, plus and minus, whatever, we get all the way around, we actually close the circle. And there's another technique. If you have a rotary table, you can put two of them together and then put this on top and rotate one way and then rotate the other back the same amount, right? So that's kind of dual closure. So these are, if you want, this is not something that's great on a great explanation on just kind of a verbal commentary, right? If you want to know more about it, look up dual circular closure or calibrating rotary tables with optical polygons if you want to have your head explode and read about circle closure and how these are used. Anyway, James, this is like super cool. And so I have an autocollimator, I have a spiffy index table, and at some point here I'll set this all up and I'll play with it and maybe see if I can get some shots through the autocollimator and we can look at some teeny tiny angle differences. So this is probably better. I think this is a calibration polygon, so it's probably sub arc second accuracy. I don't know that for sure. And honestly, I doubt my abilities to check it to that level. So anyway, James, I hope you enjoyed the little thing I sent you, or enjoying it still. And I'm certainly enjoying this. And now you guys get to see a proper optical polygon that's just spectacular. So put it away for safekeeping. So this box is kind of terrible actually because I have to touch the measuring faces as I put it in. So I'll have to maybe put a spacer under there so I can get under it a little easier, or make a handle or something. Oh yeah, maybe I could do that. Maybe I could maybe a handle would fit in there. I can make a little handle to lift it out. You know what? I think I'm going to do that. Okay. One of the things I mentioned in a video a little while back is I was playing around with, you guys all know about the three-plate flat plane generation, right? Where you can make a surface plate with no measuring equipment by just matching them to one another. Okay, that's kind of the short story. It's called the three-plate method if you want to do a little research on it. Joseph Whitworth really kind of pioneered that technique, and you can create a flat plane of basically any accuracy, depending on your patience, by matching three surfaces together and then scraping and matching those surfaces to one another. Now, that same technique actually works for if you wanted to create straight edges, right? So let's, for a second, let's have a mental leap and pretend these are straight right now. And I don't know if you can see it, but I have the edges marked with the engraving there. So the same technique, these are actually miniature flat planes, right? You can mate these surfaces together and then look at the contact pattern, and you can actually generate straight edges, okay, using that same three-plate or three-edge technique, okay? And so this is something I just been, I just love this kind of stuff, right? This self-proving and self-generating thing, and with a little bit of handwork and no measuring tools, you can do some incredible stuff, right? This fascinates me, right? And so I've been experimenting with this kind of on the down low, in the background. So what I wanted to show you though is now this one's actually pretty close right now, and there's a kind of the spotting pattern on that, and so it's actually pretty good. Did I run it? I don't think I ran an indicator along this yet. So another way you can do it is if you have a good surface plate, you can kind of true this up and then run an indicator along it and then note the highs and lows. And sometimes that's quicker than spotting them together. So to get close, and then you match them all up. So, but what I wanted to show you was kind of how I was doing that work, right? So let's do a little bit on this one here. Now I have this one inked up because I did measure this one on the surface plate, okay? And I just clamped it in a precision vise here, and then ran an indicator at each end to kind of get it leveled, and then ran the indicator along it, and then noted the kind of highs and lows, right? Let's put that on there like that. Okay, good vise. Okay, now technically, if you're really good at filing, right, you can just do this like this, right? But it's also really easy to get tipped a teeny bit that causes you some grief, right? And so me included. So I made a little kind of a filing guide, right? That keeps me perpendicular to the sides of this, right? Now, people out there going, well, why the hell does it look like that? So originally I said, oh, you know what? I'll just put some cam followers in there, and the idea was that you could just kind of change position, or even actually file like this if it was kind of a big spot, right? And this is tangent with this edge that it's referencing here, right? And then I couldn't find another cam follower in my drawer, so I had a little side plate on it, and anyway, I was using it that way, and then I said, you know what, I want to improve this a little bit, so I made another block and added it on there. Now I have a kind of a proper shelf there, okay? So I'm sure you can do better than this. This is just me goofing around, right? It does work though. So in this case, the blue is, I don't want to touch the blue, I want to touch the black. And let's see, yeah, I'll just use that one. So this is a pillar file, okay? These are really, really nice files, and I can thank my friend Robin Renzetti for kind of turning me on to these. And I've been a bastard guy for, and that's a joke, right? a bastard type file for, or a mill file, I should say, bastard cut, right? For many years, and he says, oh, you had to try pillar files, right? And I just kind of brushed it off a little bit. And then I looked through my inventory and I actually had one and I tried it and I kind of like it. Now they use a different numerical, they use numbers to indicate the coarseness of it. So let's see if I have a real coarse one here. So there's a 0, double aught and 0 are, you know, kind of like a gravel road, and number 4 or number 6 is like glassy smooth. Okay, this is a 4 here. Anyway, and they have safe edges. That's the other way you can tell them. They got 2 safe edges, which is great when you're deburring parts and stuff like that. You don't booger up the sides as much. Okay, so here, anyway, enough of that. So here's how I use this thing. I just kind of hold it down and I just draw file, and now it loads up a little bit, right? So now what I can do is easily move it over a little bit, and then I'm cutting again, like so. Okay, but what the main thing here that I'm doing is I'm making it very perpendicular. See, it kind of loads up a little bit, and this is a real fine file, by the way, too. So it keeps me real perpendicular. So I'm not rocking the thing and creating kind of a round, you know, shark fin there in the middle or whatever. So whatever you want to call it. Okay, so anyway, I just want to show that, you know, this is a simple filing fixture that, you know, one of you woodchucks out there with a good table saw could make one of these pretty easily, right? And so here's the kicker, right? You can make these as long as you want, right? So if you needed a 6-foot or an 8-foot straight edge, you can do it, right? And you don't need a milling machine, you don't need a surface grinder, okay? What you need is you need a file and a block, okay? And some Sharpie or spotting ink, and you're off to the races. So that's the beauty of this, right? If I'm on a desert island and all I got is palm trees and coconuts, right? And the wreckage of a ship with some steel in it, I can make some really excellent standards in the middle of nowhere, okay? So that's the kind of stuff I like, and that's why I like this process and why I'm showing it to you. So do with it what you will. So this next one's kind of a question that I want to put out there, and it was something I started thinking about. So here in the United States, you know, you have machinists, you got woodworkers, you got electricians, and with many of those trades, there's kind of an associated group of tools and toolboxes. So what I don't know, and I would like to know more if somebody has some good answers, is what are the typical toolboxes in Europe or England that kind of machinists or tool makers or die makers, or, you know, they have these same types of skills and needs over in Europe, right, or anywhere in the world actually, and I'm guessing that's probably similar. So when you become a journeyman, maybe you get a something the equivalent of a Gerstner box, and that's kind of a sign or signal that you've arrived and that you've served your learning time and whatnot, and all that. So here in the U.S. we have, you know, you got typical Kennedy machinists, and you got Gerstner machinists, and I'm at a loss now. I can't think of any others off the top of my head. So the question is, what do machinists and tool makers in European countries use for toolboxes? Is there a brand or a name or a kind of a tradition associated with that? So that's my question. Throw something in the comments or shoot me an email, and maybe we'll bring it up again on another Meatloaf, and we'll kind of close the circle on the on that whole thought. Okay, thanks for watching, guys, and I appreciate your viewership. Thank you.